Hello everyone, my name is Vinamnath. So today I'll be going through the Java Lambda sessions. Java Lambda sessions. Uh, so Java Lambda expressions are a part of Java programming. So to give my formal introduction, my name is Vinamnath. I have over 10 plus years of experience in software development as well as training. so so basically, without wasting much time, so we will directly dive into the Lambda expressions. First, let me introduce what are Lambda expressions. So basically, this Lambda expressions is uh, the version of functional programming which was introduced in the Java 8 version. So basically, before Java 8, it was not available. So then what made this to be introduced in Java 8? Because so at that time, when the things were rolling out like Python programming and all everything. So Python programming was almost like into functional interface programming. So to match the standards of the Python programming also, so they have introduced this Lambda expression. So this was rolled out from the Java 8 version, as I was mentioning previously. So why it was introduced? So it was introduced to give a clear representation of the method interface. We generally know what is an interface. So an interface is nothing but a class-like class-like thing which will be having so many variables and so many methods, but they have some restrictions. So we'll go into that. So basically, it is mostly used in the collection framework. So you have an idea of collection framework wherein we try to have the things like list, maps, the trees kind of thing. So you will be mostly using these Lambda expressions in that collection framework in real time. So basically, to extract the information, to filter out the data, and all. So basically, as I've told you, whenever we try to use the Lambda expression, it is the implementation of the functional interface. So generally, we don't have the functional interface approach until these Lambda expressions were introduced. So a lot of changes were made from this version of Java, from the basic Java 8 version. So what it does is it saves a lot of code by the programmer. So before this, they have to write a lot of code, so which we'll be seeing in the future of this presentation, of course. So we'll be having the two versions, like before how we used to have this usage of programs before Lambda expressions and how it was used after the Lambda expression. So basically, whenever we talk about the Lambda expression, we just define the method. Okay, so we just define the method. If we have to just write the implementation code. Okay, so we have to just write the implementation code. So we don't have to define the method again and again. Okay, so that's what the basic point is. So here we don't even require a dot class generation. So generally, whenever we write a Java program, so that Java program gives rise to a dot class. So dot class file, as you know, is nothing but a bytecode which is generated from a Java program. So a Java source code, you generate a bytecode. So that is what generally we call it as a dot class. So Lambda expression, so there is not even a dot class to be generated. So Lambda expressions, as I've told you, which will be a kind of function references, or you can also call them as lambdas. So basically, so it's a different way of presenting a method. So generally, whenever you write a Java program, you write methods, you write the functionalities inside the Java program, and we try to call it by the object. So here we don't have to do it in a traditional way. So we generally do it in some other way, so that we will be seeing. Uh, so this is not only a concept of Java programming, as I told you, it was used in programming languages like Pascal, Smalltalk, which were the old programming languages, and of course they are being used in Python programming also. So then to define, so this is all kind of things that we needed to know before going into the definition. So to go for the definition of a lambda, so to go for the definition of a lambda, so we define a lambda in simple words. In simple words, it's an anonymous function. So it's a anonymous function. So that is method without name. So generally, when we define a method, okay, so let me make a, kind of note for you so that you can understand how we define a method generally. So let me just give you an idea. So how we generally go for the methods and all. So whenever we are going for the methods, so generally what we do, so we try to write a class. Okay, so we try to write a class. So we try to write a class. So class program one. So and we try to write a method by saying void meth. So void meth int a. Okay, so we write the now we write something like system.out.println a plus 100. So we generally do write the methods inside the class. So we do write the methods inside the class. So whenever we try to go for a class, inside the class we write a method. So but what I'm saying here, so Java 8 Lambda expressions can be defined as methods without names, methods without names. So this is the name of the method literally. So this is the name of the method. So we will have the method. So we'll have a method. So basically what is a method? A method is something. So method is something which will be, so method is something which will be uh, uh, doing some functionality. So method is something which is doing some functionality. So here it is going to print a plus 100. So functionalities we can define in our own way, but we don't really have a method to go for. So that is what is called as anonymous function. So generally, before Java 8, there was no concept called function in Java. So generally, function and method are like two synonyms, literally. But whenever we have a program in Java, so we usually call them as methods. But slowly, when these lambda expressions were introduced, so slowly we called it as anonymous function. So that is that is why we call Java lambda expressions as anonymous functions, because they don't have any names. Okay, so like methods. Okay, so like methods. So in this method, what we have a parameter, we have a body. So this is the body of the method. Okay, so we have like a normal Java class method. So we have parameters, we have body. Okay, so we have the return type, of course. Okay, so in this method, I did not any return type. For example, if I want to return something from the data, so you have to bear with my writing, of course. Okay, so when I'm saying, so let me try to make it clean. So meth one, if I'm writing and I'm trying to give some kind of index over here. So let me say return X. Means what I'm doing here, I'm returning something from a method. So it means when this method is being called, so when this method is being called, so something has to be returned from the call. Something has to be returned from the method call. So that is nothing but the return. So traditionally, you can have a method with a name, with a parameter, of course, and with body, and that body also may contain a return value. Also may contain a return value. So your anonymous functions are no different. So they have methods. They can even have parameters. So they can have a body. So they can have a return data also. And it is also possible that it may throw exceptions. So exceptions are the part and parcel of the programming. So the Java programming or any object-oriented programming. So exceptions are quite common. So Lambda expressions also throw you the exceptions. So literally what I'm trying to say at the end of the day is a program, I mean a method which will be not having any name, and it will have the same properties as a method. Okay, so but what are there with methods? With methods we have name, we have but we don't have any name, and they don't have to be of a particular class. Okay, so anonymous functions or the Lambda expressions do not need to be of any of the, classes. So that is what the main logic of the function basically. So main logic of the function is they do not belong to any class. So either you to take in Python or you take up in C programming. So they are functions which do not belong to any class. Of course, Python can have classes also. That is a different case. Okay, so that is what the point here. Okay, so why? So the next question that arises is why until Java 8 things were going fine, programmers were doing the programs quite naturally. So why we required Lambda expressions? As I've told you in the beginning, Lambda expressions were the expressions introduced for the sake of making the program competitive when compared to programming language like Python and everything. And here, so if they uh, think of Python, as I've told you, so we can write the functions in Python. So we can write the functions in Python which does not belong to any particular class. So Lambda expressions are no different from that. So they are not to be a part of any of the, class. So that is where we write a function. So we write a function, so which is a Lambda expression which do not belong to any class. So that's what the first point that we need to go under the why. And then we can pass an expression around as an object and can execute on demand. So what I mean by this point, so we can pass an expression. So we can pass an expression as an object. So whenever we want, so we can execute it. Okay, so basically it enables us to treat functionality as a method argument. So it tries to uh, go for a functionality. So this parameter what you see, so that can be treated as the functionality. Also. Okay, so that's what the point. So that is why we generally require the Lambda expressions. Okay, so now going into more syntactical understanding of Lambda expressions. So generally the Lambda expressions can be given as parameters and the expression. So simply when you try to compare this, so here what I told you is, okay, so let me just go down a bit. Okay, so now if I say a method, so class method, sorry. So class 1 which contains a method, so which contains a method, so and the method should have a return type in this and you can say int of a, so which is nothing but a parameter, and this is going to be an expression. So just about .println, and I'll simply write it as SOP. So this is nothing but, so something like a is equal to plus a. So what I'm trying to write over here, I'm trying to just write combine these two and write the statement. So this is the statement that is a part of this method. So here you can also call this as something like expression. So expression which will do a task literally. So now here you can see parameters and expression. So literally, so a given, I mean followed by an arrow. So followed by an arrow. So don't check for arrow on the keyboard. It is nothing but icon and a greater than symbol. So then you give an expression. So either it can be system.out.println or any calculation or anything. So that is what here. And you can also say parameters to statements. So statements under the curly braces. Statements under the curly braces. Then don't think that you need to have parameters for uh, uh, the compulsory. So it is not mandatory to have the parameters. So we can also write lambda expressions without parameters. So we'll be looking at that. Okay, so to define all these things, so they consist of three parts. So what are the three parts? So you can see the three parts are, so the three parts are, so you can look at this list of parameters. So you can look at this list of parameters. So this is the list of parameters, an arrow mark. So you can see an arrow mark over here. And this is the body of the lambda expression. This is the body of the lambda expression. Okay, so it can be an expression, it can be a set of statements, as I told you, it can be anything as such. And then the curly braces can be making you put a set of statements, so which can be something like, for example, so this method is containing, so let me have one more method in the class. So with something like meth1, and let me have int a comma int b. So now if I want, so if I want to print system.out.println a plus b, and I want system.out.println a minus b. So literally what I'm saying, I'm trying to go for two statements. I'm trying to go for two statements. So it is also possible to have a collection of statements. So when you have a collection of statements, it is always better to keep it under the curly braces. So that's what the point under the, so that's what the point under the set of, I mean, you need to understand to have it under the curly statements. Okay, so return type also can be provided, so which we will be seeing in our example, of course. And literally how we can look at that. So you can look at this. So this is a great example that we can understand. So you can have first parameter. So this is our second parameter, and this is our state. So this is our state. So and this is the arrow token. So what you look in here, so you look in arrow token, and these are your arguments. So if you observe here, everything we wrote, but we did not give any name for the method. So whatever, so if at all you ask me to write this inside the method, so simply what I will write void method end arg1, and I will write string arg2. So string arg2, and then I will be talking about system.out.println. And so this is the way that I will transform this particular form into a method. So as I told you, before Java 8, we used to have this. After Java 8, we have been transforming our methods into anonymous functions, or you can also call them as lambda expressions. So now it makes a justification of how we can look into the definition. So Java 8 expressions can be defined as a methods without names. So it will have all the things with respect to a method. So with respect to a method, okay. Right. So with respect to a method, it can have everything. It can have everything. Okay. Right. So now let us look at how we can manage the lambda expressions or the lambda anonymous functions with zero parameters, with one parameter, and with multiple parameters. So when I'm saying zero parameters, you don't have to go for any thing under the brackets, or you can say parentheses. So under the parenthesis, you can say inside the parenthesis, you don't need to put anything as such. So that is where your zero parameter will come into the picture. So when you say zero parameter, so there is no need of keeping anything inside the parenthesis. Okay, so and you can give an equation. So system.out.println. So I have nothing to do with any of the parameters. So I will not have anything to put over here. So then we have the one parameter. So then we have one parameter. So the one parameter, if I'm saying, so you can have a single parameter over here. You can have a single parameter over here. So in that single parameter, so we can have under the parenthesis, it is not mandatory to use parenthesis. Okay, so it is not mandatory, but it is always recommended to use the parameter. So as a real time expert, I'm saying, so it is always better to use a parameter, so which will be more readable. So which will be more readable. Okay, so then you can use that P. You can use that P in your statement. It can be an expression, it can be a operation or anything as such. And you have multiple parameters, so you can just specify those parameters inside the parenthesis. So that is how we look for the lambda with 0, 1, and multiple parameters. So literally, when you have seen this, so this is two parameters, multiple parameters. Okay, so then moving forward, so we try now to go for the functional interfaces, which are nothing but our lambda expressions. Okay, so some technical things we need to understand before going or before diving into the programming. So a lambda expression always is identified by a single method interface. So generally, when I take you to the understanding of the interface, when I take you to the understanding of the interface, if you so if you can recollect what is an interface is something which is created like this. An interface. Okay, so let me say something like my interface. So an interface is a class-like construct which will have variables, and methods. But what is exactly this variable is all about? This variable is, if you just recollect the things, it is public, static, and final. So public, static, and final. And what about the method? The method will be, so let me make it more clear and legible. So your variable will be public, static, and final. Public, static, and final. So public, static, and final variable. Okay, so it is by default public, static, and final if you don't create it also. So and your method will be public, abstract, and whatever you try to give. So abstract means it does not have any body. So this is nothing but your interface. Now what we are saying over here, a lambda expression identified a special single method interface. So generally when you create an interface, it is not mandatory that it should have only a single method. It can have any number of methods. But specifically when we talk about our functional interfaces, the interfaces with a single method. So the interfaces with a single method. So that is what is called a lambda expression. So a function interface. Okay, so which is determined by the compiler. So which is determined by the compiler and is used as a reference for the lambda expression. So this has to be identified by the compiler. So in order to get identified by the compiler, So we use something like an annotation. So we use something like an annotation. So which can tell you or the other developers who are looking at your program that it is a functional interface. It is a functional interface. So you just have to put an annotation called functional interface, so which will make it more readable. So which will make it more readable. Okay, so which will make it more readable. And whenever I'm talking about readability, so when you code, readability is quite a bit important thing. So whenever I'm saying readability, so function interface can be marked with the informative annotation at the rate function interface. So that can be used to inform to the other developer. So who is the candidate for keeping the functional interface? The interface with a single, so the interface with a single method. The interface with a single method is being regarded as the functional interface. So that is where you are trying to inform the developers who are looking at your program, of course. Okay, so that is what happens generally in the real environment. So you may not be the one who is using your own program. So that might be others which who will be using. Okay. So then the next question that arises is, so we have seen why, what. Okay, so why, what, and all. So now we have to answer a simple question where we have to use. Okay. So where we have to use is, so where we have a requirement of single interface, I mean, single method under the interface to be used. So there we can go for. Okay, so where we have the use of only one abstract method. Okay, so can have any number of default method, but they have only abstract method, one abstract method. So some of the realistic examples of functional interfaces are comparator, runnable, and action listener. Okay, so these are the three real examples for the functional interfaces. How they are the real examples. So you might not have went through comparator or action listener. Maybe if you are working in GUI programming, so you might have went through this action listener, and when you are going with the collection, so you might have went for the comparator also. So runnable is more of a thread programming. So more of a thread programming. So then how I call them as functional interfaces, because they have only one abstract method. So they have only one abstract method. So generally how we convey that? So we convey that so we convey that with the help of an annotation called @functional interface. Okay, so what is the interface? Comparator interface. Okay, so we have only one abstract method, int compare. So T is the data type, of course, and T is the data type. Okay, so only one abstract method. So int compare. So now you might ask a question like, we haven't given any abstract or anything here. So then how come it has become an abstract? Just now I told you that if you don't give anything, if you don't give anything, so it will be by default an abstract. So it will be by default an abstract. So that is why we can confidently say that it is an abstract method. So what is the method that is available? The compare method, the compare method. And then we go for the runnable. So we also know that, so we have a run method. So if you provide or if you don't provide, it doesn't matter, it becomes an abstract method by default. Okay. So then going for the action listener, so definitely it is a GUI related thing. So it has a method called action perform, so which is a function. So now if we are going to develop a code which will be using these three things. Okay, so that's what we are going to do now. So before and after. So just now, as I've told you, before Java 8, what we used to do, and after Java 8, what we are going to, what we are doing right. So when we look into that, So this is our functional interface as we have seen just now. So as we have seen just now, the functional interface. And before Java 8, when there were no Lambda expressions around, we used to implement something like this. Comparator, student ID comparator. So this is the reference that we are creating out of the comparator. So just I'm taking one student uh, class. Okay, so this is like a generic means comparator, so of the student type. So what we are doing here, so we are overriding the compare method. So how I'm saying that I'm overriding the compare method, because when you are implementing the interface, it is mandatory to override the compare method. So it is mandatory to override the compare method or any abstract method that is available in the interface. This is before the Java 8. So before Java 8, this was the thing that we had to do. Of course, you can also create a class which will implement this comparator. Okay, so something like, okay, so if you create a class, okay, so another way. So another way of doing it is, so class, I'll say one, which will implement, the comparator, So class one, which will implement the comparator. Okay, so then you have to override this anyhow. Okay, so instead of creating one class, so we use a concept of implicit class. So which will be helping us, to create the object of the comparator and use the compare. So use the compare method under this. Okay. So then after the Java 8 Lambda expressions, so what we are doing here, if you see, so you see a great reduction in the code. So what we need to use? We need to use the methods parameters, and we need to use the arrow symbol, and we need to have the expression. So here the expressions are S1's ID, the student's ID. So every object will have an ID. So that ID and minus S2's ID. So just I'm trying to have the IDs of these two students to get subtracted. So the same thing I'm doing. So here I'm writing a return statement. So here no need to have any return. So directly this value will be written. So this value will be written. So this is doing the same job as this is doing. This is doing the same job as this is doing. So literally before Java 8, this was the thing that was happening. And after the Java 8, this is the thing that is happening. So, and it is not mandatory to use a Lambda expression. So you can go the traditional way as well. So there is not a big issue, but literally you are saving a lot of memory if you are not doing this. Okay, so you are creating a new and all. So those things. Okay, so then if you go for the next example, when we have runnable, so before Java 8, we used to run this and try to have our own implementation. Okay, so you can call it as anonymous in a class or implicit class also. Anonymous inner class is the exact name that we can give for it. But after the Java 8, so here you don't have any parameters. So no parameter specified. So then you can print whatever. So this was the example for the Java, after Java 8 using the runnable functional interface. So why it is called a functional interface? Because it has only one abstract method. So don't forget that thing. So you can say an interface as a functional interface if it is having only one abstract method, and then you are going for an action listener implementation. So how I can implement this action listener? So generally, as I've told you, action listeners are GUI based programs. So GUI based programs are nothing but graphical user interface programs, so where you can have an anim kind of things. So here you are creating a new label, and in that label is supported by the button. Okay, so you are adding action listener. So those who are proficient in GUI programming can better understand this. Add action listener. So new action listener. So this is the action listener that we implement as a parameter, and then we are setting the text to it. Okay, so how we can implement that using Java 8, I mean after Java 8, okay, in Java 8, of course, in Java 8 and after Java 8, of course. So you are just saying action event key set to label set. So that is how these things are done easier. These things are done easy. Now, the next question that arises is what happens in the background? So what happens in the background? So what generally uh, uh, the compiler does, and what basically is done in the behind the scenes. That is what it is. So we need lambdas basically. So they are having less code. Okay, so as you might have observed here, so we require very less code. So we require very less code, so we don't have to worry about the implementation, the classical implementation, of course. So then they are not a new function type in the VM level. So VM stands for virtual machine. So you can say you might have seen JVM. Okay, so you might have heard at least. So VM is nothing but the Java virtual machine. So it is mostly about the compiler level. So compiler level in the sense it has to be understood by the compiler so that it has to do the transformations and everything. Okay, in the form of related defined function interface. So compiler is, so the point that here to be noted is, so the compiler infers our lambdas as functional interfaces. Okay, compiler infers our lambdas as the functional interfaces. So it's all about the compiler's job. Okay, so what it does, it whenever it sees the lambda, it simply create a static method. So static method, if you can go back and understand what is a static method. So when a method is declared static, so now for example I have so I have a method to be declared. Let's say I will create a class. So let me improve my writing over here. So I will say class 2, and I will create a method. So void method 1. So and let me write system.out.println non-static, and here I will write static method 2, and let me go for system.out.println static. Okay, so literally what happens whenever you call them, so how we need to call them? So 2t is equal to new 2. So we call them in this way. I mean, we create the object in this way. So we can say t dot method 1. So it is an instance method. So this is an instance method. An instance method requires an instance to be called. But when you go for the static method does not require any instance. It can be called directly. It can be called directly when it is inside the class, and it has to be given a class name instead when it is not called inside the class. So there are two ways. Okay, so it belongs to the class, and in the same way, as I've told you, so this becomes a static method. Okay, so it becomes a static method and resolve related functions and in the invocation type. So in the same way as a static method, whenever it is called, it does not require any reference. So that is why you might have observed. So nowhere we have a reference, so directly it can be called up. Okay. And finally, so there is something called invoke dynamic. So invoke dynamic, so which will be a part of the VM. Okay, so part of the VM. So this was introduced in Java SE version 7 only. So it is going to use that invoke dynamic. Okay, invoke dynamic, so which will be helpful for calling that functional interface. Okay, so when you say when you use lambdas, so you can use lambdas in different ways. Okay, so single statements in a body. Okay, so single statements in a body in the sense you can have the variables. Okay, so you can have, so again going for the ways in which we can use the lambda expressions. Okay, so single statements in a body. So what do we mean by single statements in a body? So we can use the parameters so directly, and you can have an expression. So don't deviate from the the main syntax. So this was the syntax, right? Parameters and the expression. Implicit target types. Implicit target types in the sense, so we can, okay, types of input variables can be omitted, and this can be input by the compiler. So the types can also be omitted. The types can also be omitted, and you can say implicit single target type. Parentheses are optional. So without parentheses also, as I told you, we can look for them. Okay, so then explicit type in the sense, so you can have the parenthesis. Okay, so you may not use the parenthesis, and you can directly print the statements. And if you want multiple statements, so you can use the multiple statements. So in this way, you can look for them. Okay, so now what we'll do is, so we'll directly directly jump to the some of the examples so that I have installed for you, so which will make your understanding of the understanding of your uh, Java, this one very easily. So let me create a pack. Let me create a Java project for our session. So let me say Starof. Okay, so Starof. So next, say finish, and let me create a package. So let me create a package, calling it as Lambda. So let me create. So right click here and let me create a package. So let me create a package and call it as Lambda expression pack. Okay, so Lambda expression pack, and so I'm using the IDE Eclipse IDE. So NetBeans also you can use, not an issue. So just right click here. So let me clear all these programs and right click here, say new. So we'll create a class. I'll try to take up the same class name. So the class name is Lambda Expressions. Okay, so let me take the class name as Lambda Expressions. You know, when you don't take up the same class name, so then it will be an issue. So Lambda Expressions, finish. Okay, so because of the time constraint, I'm not typing everything. I just copied everything. So the program here is going for, so the whatever you learn theoretically, when you look at a program, it will be more fun. So according to me. Okay, so this is a package, and here the program is all about creating an array list, and we are going to print only even numbers from the list. So we are going to create only even numbers from the list. So my idea is to take up an array list. Okay, so to give you a brief idea about an array list. So when you talk about an array list, literally, so what is an array list? Array list is something which is a collection of elements, Okay, so when you say array list, so for many people might be thinking that array and array list may be same. So there is a lot of difference between a general array and array list. So where an array is nothing but a no, static array. So static one, so wherein you cannot have any changes. So array list is a dynamic one where you can have the changes, you create the values, you add the values, etc, etc. Okay, so what we are trying to do is, so we are trying to have an array list, Okay, so in the array list, I want to have the elements 5, 6, 7, 8, 9. Okay, so in order to put the elements, what I have to do here is I have to create an array list object. Array list object. How to create an array list object. Okay, so how to create an array list object? So array list, so integer. So it means I want to put only integer types into the array list. So you might be thinking, so basically int is for the integer. So but when you look at collections, the collections will not allow you to use non-object oriented things. Okay, so in Java also there are some non-object oriented things to talk about, so that are nothing but our basic data types. So array list, your integer type only, so we'll create a variable, so which will be the reference for the array list object. And now we are adding those elements to the list. So when you say this, so by default, so there will be an array list of 10 values, so which are not allocated with anything. And then we are going for 5, 6, 7, 8, and as I told you, so we can have add of 9. Okay, so we'll have 9 up to 9. So we'll have 9 elements. Okay, so we have 9 elements. So I mean, sorry, we have 5 elements. So which are okay. So generally they follow the indexing and everything. Okay, so this is an array list. So now what I want to do is I want to have the even numbers listed out from. I want to have the even numbers listed out from here. Okay. So for that, what I will do is I will just use a lambda expression. So I'm just using a lambda expression. So that lambda expression, what I'm doing is I'm using for each loop. So generally, when I want to go through the list, so when I want to go through the list, so generally I can write something like, okay, so this is without using lambda. So without using lambda, so what I can do, so I can say for, okay, so for I will say object. Why I'm saying object? Because I can even say integer also for object. So for each loop I'm using, so that I can match the content. So for I colon, so the list of elements, and then I will say if, okay, anyhow, okay, so anyhow you can, as it is an integer, so you can also use int, not a problem. So int, so if I mod 2 equals to 0, if I mod 2 equals to 0, so you just print system.out.println, system.out.println the I value, so I value. Okay, so let me comment this for a while, and let me save this and run the code. So now, okay, 1 second. So I think this is running the previous code. Okay, so public static void main string var, yes, it's fine. Okay, so let me say control F11. Okay, I don't know why it is running the last code. So this once again. Okay. So why it is running the previous code? So lambda expressions. So public static void main. So this is running the last code. So public static void main. So maybe I'm using, yeah, that's the reason. So I'm using the wrong name here. So let me refactor it. So refactor it, rename. So let me rename it to so LAMBDA. So save this. Okay. Now let me run this again. Okay, now you can see 6 and 8. So 6 and 8 are printed. So this small spelling mistakes so will definitely affect us. Okay. Okay. So now I'm trying to blur this one, or I want to comment this one, and then I will go for this. So same thing, but I'm not using a normal for each loop. I'm using a for each. Okay, so I'm using a for each. So for each is a kind of a stream API, so which is available. So for each n, okay, so n which will be validating n mod 2 equals to 0. So if n mod 2 equal to 0, so what to be printed? So that value to be printed. So what we are trying to have here? So same thing. So same thing what you have done over here. So same thing what you have done over here. So the same thing you are doing here. So you are sending each and every element. So here as well you are sending each and every element for the into the n value and it is being validated here, and if it is equals to 0, n will be printed. So 6 and 8 are getting printed because 6 and 8 are getting printed because so we are having a logic to go for the checking for the event. So what we are using here, list under list for each n arrow what that we are using. So this is the parameter, and we are going for the value. So this is how we can write the code. So we can write the code for finding the the list of and finding the even numbers in from the list of the values, list of the integers which are given. Okay, so this is one of the examples. So to look at other example, so in the other example, okay, so let me have an example wherein we try to reverse a line. So here we are going to use the interface, the functional interface concept. So previously it was like our own, the internal things. So, but here I'm going to use, okay, so let me create a class called main here. So let me say new class. So I will use a class called main. So main, we run this, and what we are going to have over here, we are going to have the interface. So we are going to have the interface. So what we are creating here, we are going to create the interface. So my interface. So let me save this. Okay, maybe my interface in the presentation. Okay, so okay, so here, so you have a method called string citation and the functional interface at the rate functional interface. Okay, so I don't know why this. Okay, so let me take away this. Okay, so abstract string reverse. Okay, so string reverse. Okay. So now what we are doing here, so we are going for a regular expression here. So what we are doing, we are going to use my interface. So this becomes a functional interface by having only a method, only a single method which is abstract, only a single method which is abstract. So now what we are doing, so we are declaring that my interface, and we are saying the str. So str is nothing but the parameters. So and the result. So for I is equal to str dot length. So what is str's length? So whatever you are providing, so reverse of lambda. So literally when you make a call, so where this ref will be going, ref dot reverse. So lambda will be the string now, and what we are going for. So we are going for its length. Okay, so if you try and understand over here. So here if we observe, so lambda is being taken up as the str. So lambda's length minus 1. So for I is equal to what is lambda's length? 1, 2, 3, 4, 5, 6. So I is equal to 6 minus 1. So that will be I is equal to 5. So I is greater than or equal to 0 and I minus minus. Okay, so basically where it starts from? It starts from 5 to 0. Start from 5 to 0. So then result is equal to char at I. So result is equal to char at I. So what is char at I? So the fifth character is L. So sorry, character is A. So fourth character is D. Okay, so 0 to 0, 1, 2, 3, 4, and 5. So 5 is A. So 4 is D. So it is just doing a reverse. Okay, it is just doing a reverse. And every time the result is getting concatenated with the values. So result is getting concatenated with the values. So this reference will go on to the string, and that string, so we are going on reverse from 5 to 0. So 5 to 0, and then we are returning that result. Okay, so that is what is happening over here. So this is what the uh, lambda expression usage on the my interface, so which is a functional interface, which is a functional interface. So just if you run this program, so you can see the output, which would be lambda reverse. So what you are getting? You are getting 5 to 1. So because of this particular, okay, so this is how we are developing the code. So we are developing the code. So this is the whole equation. So if you, so because of the length, I have to put that here. So this is the whole code. So up to here. Okay, so that's the whole thing. So if we write this, so this is how we are doing it. Okay, so you can even write something like this. So this, so to make you better understand, you can write it like this. So result is equal to, so it doesn't matter. So it doesn't matter when you try to have it somewhere. So this also is, so this is multiple statements. So you can have multiple statements. So you can have multiple statements, and finally you are returning the result. So you are returning the result. So this is the way that you can look at this. So this is how we are passing, and then this. Okay, so this is the other program that I wanted to discuss. Hope you have learned a lot of things. Thank you everyone. So any doubts, any questions, you can please ask me. Okay, thank you.